more practice with the 45, 45, 90 triangles and the 30, 60, 90 triangles. Those are the two special right triangles. And so if you see on the website, or if I send you out a remind text and it says something about, hey, test over the special rights, I'm referring to the 45, 45, 90s and the 30, 60, 90s. Those are our two special right triangles. So for the first two problems on SpringBoard page, what is this? I don't remember. Yeah, okay, 293. I signed number 5 and number 6. Both of these are 45, 45, 90 triangles. We know that because of the instructions. It straight up tells you. However, I'm not going to do that on a quiz or a test. I'm going to have you use your deductive reasoning and figure out what type of triangle you are dealing with. And so there's an array of ways that I could do that. For instance, I could show you that it is a right isosceles triangle, and then you would know that that means your base angles are congruent, and then you could conclude that this has to be 45, that has to be 45, or I could have just marked that these angles were congruent, and that means that it's a 45, 45, 90 triangle. So lots of different ways that you you've been exposed to, not only those 3 ways that we did last class. It was considered the warm-up that transitioned into our notes, the homework that you got answering questions over. So, anywho, number 5. This is a 45, 45, 90 triangle, and so what I need to see on the quizzes and tests, the work that I need to see from you is you identifying what type of triangle you have, and then below that, writing the extended ratio that the side lengths always follow. And so for this, the sides opposite the 45-degree angles are your legs, and so those are always going to be congruent. So we've been using L to represent that length. Then the hypotenuse's length, which is always, the hypotenuse is always opposite the 90-degree angle. It is the length of the leg times the square root of 2. So all we got to do is just plug in what we're given and solve for the missing side lengths. What we are given is that the hypotenuse's length is 17. So in green ink is what we're given. And then in red ink, I'm going to go ahead and do the work that's necessary of solving this problem. So what we have is that the length of the hypotenuse, which in a 45, 45, 90 triangle, the length of the hypotenuse is the length of the leg times the square root of 2. What we have is what we're given is that the hypotenuse's length equals 17 units. So now we have an equation that we need to solve. This is the variable times it's being multiplied to some value. And so if we had equations in Algebra 1 like this, if we need to get the variable by itself, we did the inverse operation with that same exact value on both sides of the equation. The inverse operation being division, and then whatever value was being multiplied to that variable. So same thing here, it doesn't change anything. The variable L is currently being multiplied by square root of 2, so I need to divide the inverse operation by that same exact value. Therefore, they will simplify to being just 1, and then 1 times L is just L. Some of your algebra teachers may have said that they canceled each other out. Well, it's not like magic, they go away. It's what's happening is it's being divided by itself, which equals 1. So that's why it's just L left over. But whatever you do to one side, you have to do to the other. And so technically, the correct value of our answer is 17 divided by the square root of 2. But you're not allowed to have radicals in the bottom. You can't have a radical in the denominator because this is an irrational number, and our denominators need to be rational numbers. So what we do is, they call it rationalizing your denominator. We need to multiply top and bottom by whatever radical is in the bottom. In this case, it is square root of 2. Now what we're taking this fraction, 17 divided by the square root of 2, taking that fraction, and really what we're multiplying it by is just a big ugly 1. Because square root of 2 divided by itself will just reduce down to 1. So we're not changing the value of this fraction here. We're not changing the value because we're just multiplying by 1. We're going to just multiply straight across. That's how you multiply fractions. So I have 17 times the square root of 2 which is just 17 times the square root of 2. And then on the denominator, we got square root of 2 times itself. And the reason we did that is because when you take that product, it becomes a rational number, just 2. It is the value of 2. What I want, I like improper fractions. So 17 square root of 2 divided by 2, that's perfect. That's what I like right there. It's okay, but it can get messy if you start mixing decimals and radicals. But if you put 8.5 times the square root of 2, I wouldn't count off. I mean, that's the correct answer. But I hesitate when you have decimals and radicals. It gets messy. So I prefer this, but this is the same exact value using decimals. So, any questions on number 5? Let's move on to number 6. This too is a 45, 45, 90 triangle. So I'm just going to leave this up here. So on a quiz or test, I need you to identify what type of special right you're dealing with. I then need you to write the extended ratio. This is you conveying to me that you know how the side lengths always work. And then you can write down what you're given. What we're given is that one of the side lengths is 4 times the square root of 5. And so then in red ink, this is your work that you would show. Well, if one of the legs is 4 square roots of 5, that means the other one, which it's congruent to, also has the length of 5 square roots of 5. And then to determine the hypotenuse is whatever the length of the leg is times the square root of 2. So our hypotenuse's length is, well, the length of my leg currently is 4 square roots of 5. And we need to multiply that by the square root of 2. So when we've been multiplying radicals, multiply the numbers that are on the outside. So 4 is the number on the outside for my first radical, and then there's an understood 1 to be in front of this one. So 4 times 1 is just 4. Then we multiply the numbers on the inside. So 5 times 2 is 10. You can't reduce the square root of 10, so this is your final answer. The length of the hypotenuse is 4 square root 10. Questions on this one? On the back of this page, it says, dealing with a square. Dealing with a square. Go ahead and draw a quick diagram, because everything in geometry, you need a diagram, you need something to look at. The definition of a square is that it's a parallelogram with right angles and 4 congruent sides. It's a rectangle and a rhombus. So I've made that evidently clear in my diagram. And what we're currently looking at is the diagonal, which is 14 inches. Now, when you draw in one of the diagonals of a square, it breaks it up into 2 right triangles. And it happens to be 2 45, 45, 90 triangles, because it is a right isosceles. So that is the type of triangles we are dealing with. So I need you to identify by writing the 3 angle measurements. I need you to write this on a quiz or on a test. 45, 45, 90. And then below that write the extended ratio that the side lengths always follow of that triangle. Then plug in what you know. What we're given is that the hypotenuse of these right isosceles triangles is given to us as 14 units. So we need to solve. So in red ink, this is the work. We know that the hypotenuse, which is the length of the leg times the square root of 2, is equal to 14. That's what they give us. So this is a simple equation. One step. All you got to do is divide by the square root of 2 on both sides. So we have our value of 14 divided by the square root of 2. However, this is This is not a proper way to represent fractions because you need the denominator to be rational, not irrational. So we're going to multiply top and bottom by the square root of 2. Multiplying across, we got 14 square roots of 2, and then square root of 2 times itself is just a positive 2. Now on this one, we can actually reduce this end result. Because if I have 14 of these square roots of 2, whatever that is, I don't know the number memorized, but let's just say we had 14 apples. Right now I need half of that. So if I had 14 apples and I was going to give half away, well, when I give that half away, they don't change into bananas or something, or they don't change into something different. So here's currently 14 of these square roots of 2. When you take half of that, it's still going to be some number of these square roots of 2. Just half of whatever you had originally. So half of 14 is 7. Okay, we've discussed this from time to time again, and when we multiply radicals, the coefficients are affected by one another. So if we have this example, 2 times 4, that's where we get 8. 2 on the outside does not affect the 10 that's on the inside over here. This 7 that is underneath the radical symbol does affect that. That's how we get 70. So same thing with dividing. This 2 is no longer underneath the radical symbol, so it's not going to affect this one. This is a coefficient, and so it's only going to affect the coefficient here. That's why it's 7 square roots of 2.